Welcome to this short tutorial from Pico Technology. Today we're going to have a quick look at different ways of capturing intermittent glitches. I've simply hooked up one of our scopes with the signal generator output, looped back via a BNC cable to one of the input channels. The first thing we need is a glitch to try and capture. So I'm going to use our arbitrary waveform generator feature built into many of our scopes. So first thing, I'm just going to increase the number of samples it's going to output and generate a couple of hundred square waves. I'm now going to zoom in on one of these square waves and corrupt it. Just use one of our drawing tools. Let's make a bit of a mess of this square wave, perhaps a similar signal if two data buses had collided. So I'm now outputting this signal, but because it only happens once every 200 square waves, we're not seeing it on the screen. This is a normal display mode that updates, say, 30 times a second. There we actually caught it. So what we could do is stop the scope and we could scroll back through the last 1,000 or so waveforms and eventually we'd find it. But that's not a very efficient way to work even for a signal that only happens once every 200 times. If it was once every million times, we'd be wasting an awful lot of time trying to find it. The traditional way of finding intermittent glitches is to use a display persistence display mode. This is overlaying thousands upon thousands of waveforms on top of each other, and you can see where you've got a red trace, this is the signal that's happening most often, and the blue trace is the signal that's happening least frequently. So with that knowledge you could probably set up an advanced trigger to try and capture this short pulse here perhaps. This is a pretty easy example, but one of the disadvantages of persistence modes is that all the waveforms are overlaid on top of each other, so if you've got more than one fault condition it can be very difficult to see what's happening, and you don't really have any idea of how often each event occurs, and you can't capture or print the actual fault condition single waveform on its own. So there is a better way of doing this. What we do is we move across to our rapid trigger mode. This is a hardware-based triggering mode which can capture up to 1 million waveforms per second. So if I click on here, it's actually already put 1,000 waveforms into the buffer. If I click go again, it's instantly collected another 1,000 waveforms. And as before, we could scroll through all these signals and look for the glitch. But to give us a bit of help, we can also use our mask limit testing option, and we can add a mask. We can ask it to auto-generate a mask. Let's pull that down to about 100. This is just setting the margins around the waveform that we're going to draw. And here we go. We've now got our mask up on the screen. And what the software will do now is it will scan through all the waveforms in the buffer and highlight the areas where the signal has crossed the mask. And our waveform buffer tool has an option here to show just mask fails. So here we have a display that shows us that's 10 waveforms that actually failed. We can actually, each time I'm clicking one of these, it might be a bit difficult to see on the screen, but it's actually displaying a different one of the failed waveforms. And I can clear this mask from the tools menu, and I've got my actual waveform. I can print this, I can save this, I can zoom in on it and see any detail I want. So in summary, this is a quick way. It's very reliable and it will capture 1 million waveforms per second, and the mask, you don't have to know what the glitch looks like. The mask limit test will enable you to just select one good waveform and then it will find all the ones that don't match that mask. And you've then got the actual waveforms to save, print, email to customers or clients. So it's a very efficient way of finding intermittent glitches. Thank you for your attention.